Hello and welcome to all camps. Today we are going to learn how to change electric energy into a chemical energy by using electrolysis. For the term electrolysis here, it's divided into two sections, electro which means electricity, and the second section here means separate or break down. So the whole word means here separate or break down chemical compounds by using electricity. And electricity is really simple. Here's how you can draw it. You just draw two lines, one is shorter than the other. The short line represents the negative pole, and the taller one represents the positive pole. And they are connected to the circuit. The circuit represents straight lines. And the flow of electricity here should be starting from the negative, going to the negative pole, which means here the positive attracts all the negative electrons towards itself. So the negative electrons will start to flow from this part till it reaches the positive pole right there. This is called the flow of electricity. We are going to do the same here, but we are going to change the copper wire by using different materials or different chemical compounds, as we are going to say. But before that, we have to know some important definitions, and there are 5 definitions. The first one here is the battery, which is simple. Here's the battery or the cell. And the negative terminal here, which is connected to the wire here, which is made up from copper or zinc. Here in our example, call it cathode. So cathode here is the negative terminal, and this is the term we use to describe the negative terminal in our battery. On the opposite hand side, you will find the positive terminal. And why it's positive here? Because it's connected to the positive pole of the battery. And why it's negative here? Because it's connected to the negative pole of the battery. So the positive terminal here, we call it anode. So for anode here usually represents the positive terminal, and the cathode here represents the negative terminal. Why it's positive? Connected to the positive. Why it's negative? Because it's connected to the negative pole of the battery. Now let's talk about the solution here. The solution here, as you can see, it have a blue color, and blue color here represents copper sulfate. Copper sulfate. Or we can write simple right here SO4. So for copper sulfate, it's a chemical compound that is made from metal, copper, and sulfate group. And here, as you can see, this compound is pretty stable, but when it's forced or when it's under the condition of electricity here between the two terminals, it has to divide. And the copper here will lose electrons, change into positive 2, and the sulfate group will change and gain electrons, and it will change into negative 2. According to the effect of electricity, electricity will attract the negative electrode. So the negative electrode or the negative terminal, which is called cathode, will attract the positive ion. So here's the 4th definition, which is called cation. And cation here means the positive ion, which is attracted to the negative cathode. While on the other hand side, as you can see, copper is positive because it lost an electron, and sulfate is negative because it gained electrons. So the negative sulfate group will attract it or will be attracted by the anode, which is the positive terminal. Now we are going to see how this is going to work and how the copper is attracted to the cathode and how the sulfate group is attracted to the anode. And now look at that diagram and let's start to identify each part in the circuit. Now number 1 here, yes, is cell. The negative terminal or the negative electrode, which is called cathode. The positive terminal is called anode. Both of them in this example are made from copper. And the electrolyte is called copper copper sulfate, and we can call it electrolyte. For copper sulfate, it will be separated into two ions, positive ion and negative ion. Now, let's start from the beginning. This is the negative terminal and this is the positive terminal of our cell. The negative terminal is connected to the electrode, which carry negative charge because it's connected to the negative, as we said before. So the negative should be attracting positive, and the only positive here in this electrolyte is called copper. So copper ion, positive ion, will be attracted to the cathode on the electrodes. On the other hand side, you can find the anode, which is positive, which is attracting the negative electrons to itself so the circuit can work. As you can see here, there is a sulfate group which is negative. The negative ion, which is called anion, should be attracted to the positive anode. So the sulfate group will be here on this electrode. Now here's my question. Can you purify salty water by using electrolysis? Can we? Yes, we can. Now let's talk about one of the main topics here and how we can use electrolysis into our real life. This is called electroplating or electric plating, where we used one of the electrode. This is Ag silver, and this is the fork that we need to cover it by using the silver, right? As we said before, that should be battery or cell right there. The positive is here, negative is right there, and we said before that electricity is flowing from the negative to the positive. And we will connect the negative terminal to the fork that we want to plate, and we will connect the positive terminal to the silver that we want to use to plate the fork. The electrolyte here will be silver nitrate, and silver nitrate is an ionic compound which is consists from positive and negative, and anything that is connected to the negative pole of the battery should attract the positive ion. So here's my silver nitrate, the electrolyte or the solution that I'm using here. Silver is the positive and nitrate is the negative. For the positive ion and the negative ion, we are going to discuss them later in another video. But here the silver is positive, so which one should be attracted to the other? Okay, silver, correct. Silver will be attracted to the cathode. So the cathode itself will be attracted, or the fork itself will be covered by silver ions, not silver atoms. While on the other hand side, the silver itself will be attracted, or the nitrate group in O3 will be attracted to the silver right here to form silver nitrate. After a period of time, you will find that the silver or the silver electrode or the silver terminal will be reduced, which means some of the parts will be reduced. And on the other hand side, you will find some part at the fork starts to be shiny because we have added silver to it. Of course, this electroplating or this electric plating is so expensive, but it's one of the real life situations that we can use electrolysis, or we can use electrolysis in our real life. Now let's check your understanding. Which statement is true? An anode is the negative terminal in a device. A cathode is the positive terminal in a device. Cations are negatively charged and move towards the anode. Anions are positively charged and move towards the cathode. If you know the answer, write it down in the comment section below.